Hi students, today in this video we are going to see how to name the compounds, coordination compounds, how to name. The previous video we saw some terminologies and ligands types, how to name them, now we will see. I think the previous video I have given you the ligands list like CN -1, F -1, neutral ligands, aqua, amines, like that. I have given you the ligand list. You can have that list with you. Now let us start naming the compounds. Alright, so let us go to the video. So IUPAC, so International Union of Pure and Applied Chemistry, that's a full form of IUPAC. So we would have seen in organic chemistry IUPAC. So here we are going to see coordination compounds, how to name them based on IUPAC. Okay, now let us start. For example, let me take the simple example K4 Fe CN6. K4 Fe CN6. How to name this compound? Always start with the positive ion. Always start with the positive ion. So potassium, first letter capital letter. So always while naming the IUPAC you should start with the positive ion. Then we should go to the ligands. So how many ligands are there? 6 ligands are there. So hexa, cyanido. Cyanido, why? Because CN is a negative ligand. So negative ligand always have that sound O, right? So potassium, hexacyanido, and when you split this compound, this 4 belongs to the FeCN4, 4 minus, right? So when I put this in water, when I take this complex and put it inside the water, it will split as K plus FeCN6, 4 minus, right? 4K plus, how it will split? 4K plus FeCN6, 4 minus, right? So the charge on the complex is 4 minus. Now let us find the oxidation state. X plus 6 into -1, which is equal to -4. So what happens? X minus 6 is equal to -4. X is equal to 2. Okay. So potassium hexacyanido, cyano also correct only, but that is old way of naming. So hexacyanido, and since the charge on the complex is negative, so we have to use the Latin name ferrate 2. Okay. Once again I will repeat, always start with the positive ion. So how will you know that it is a positive ion or the negative ion? If you have the complex, left hand side is the positive ion and right hand side will be the negative ion. Is that okay? So potassium hexacyanido ferrate 2. Alright. So when we use the Latin name, whenever the charge on the complex is negative, we use the Latin name. Alright. So now let us go to the next compound. Hope you guys understood. How to name this? Again you should start with the positive ion, potassium hexacyanido, again ferrate because it is the charge on the complex is negative, 3 minus it is. So X plus 6 into -1 is equal to -3. So X is equal to 3. Ferrate 3. Okay. Potassium hexacyanido ferrate 3. Understood? Now let us go to the next. Now how to name this? So now you have cobalt and NH3 6 times Cl3. So how will you name this? Hexaamine. Always start with the, we don't have the positive ion, so start with the ligand. So hexaamine, double M. Okay, cobalt. Now If you put this complex in water, it will split as CONH3 6 times 3 plus, because this will split as 3Cl minus. This is called counter ion. Whenever the ions which is outside the complex, it is called counter ion. Is that okay? So here Cl3 minus. So charge on the complex will become 3 plus. Now what about the amine ma? Whether it is a positive ligand or negative ligand or neutral ligand. You know very well it is the neutral ligand. So its charge is 0. So directly you can take the cobalt oxidation number to be 3. Is that okay? So hexaamine cobalt 3 chloride. Understood? Hexaamine, see we don't have the positive ion here. So you have to start with the ligand. Okay? Hexaamine cobalt 3 chloride. Hexaamine cobalt 3 chloride. Is that okay? So I have a complex like this. Now how to name this complex? Again, we don't have a positive ion here. So what we should do? We should start with the ligand. But you have more than one type of ligand. So you should arrange by the alphabetical order. You have to arrange by the alphabetical order. So you have aqua, right? So aqua, tetra, aqua, dichlorido, tetra aqua dichlorido. Now this is -1, right? So charge on the complex is +1. This is 0. This is -1 charge. So what is oxidation state of ion? X plus. So this is 0. So I am not taking 2 into -1 equal to +1. So what will happen? X minus 2 is equal to +1. X is equal to 3. So tetra aqua dichlorido iron, because it is the charge on the complex is plus, iron 3 bromide. So tetra aqua dichlorido iron 3 bromide. Is it fine? Next, suppose I have NiCO 4 times. So you know there is no charge on the complex, which means it is a neutral complex. So charge on the complex is 0. Okay, it's called neutral complex. Now you know very well that carbonyl, CO means what? Carbonyl. So if it is a carbonyl and it's a neutral ligand, so its charge is 0. So how will you name? Tetra carbonyl nickel 0. Okay, tetra carbonyl nickel 0. Okay, so you have like 4 neutral ligands. Okay, so tetra carbonyl nickel 0. Why 0? Because charge on the complex is 0 and it is a neutral ligand. So therefore total charge is 0. So tetra carbonyl nickel 0. Understood how to name this? Yes. Now we will go to another one. So this is the next complex. So how to name this complex? Tetra cyanido. Okay, it is cyanido because CN. So tetra cyanido nickelate. Why nickelate? The charge on the complex is negative. So nickelate, what is it? Oxidation state? X plus 4 into -1 is equal to -2. X minus 4 is equal to -2. X is equal to 2. Okay. Tetracyanidonickellate 2. Right. Understood how to name it? Yes? Another one? Okay. See, whenever you have more than one type of ligands inside the complex, you have to arrange by alphabetical order. We have to arrange by alphabetical order. So, how to name this? Pentaamine, nitrito, okay, nitrito N, cobalt. Now you have to find out the oxidation state. Charge on the complex is positive, so it is cobalt only. Cobaltate will not come. When it will come? When the charge on the complex is negative, then we say it as cobaltate, okay. Otherwise it is cobalt only. And now let us find the oxidation state. So this is neutral ligand, this is -1. So X -1, and you know this is 2 Br minus, right? So charge on the complex is 2 plus. So X is equal to 3. So cobalt 3 bromide. If you write dibromide also correct. Simply if you write bromide also, it is correct only. Dibromide is also correct, bromide also correct. Is that okay? Understood how to name it? Yes? Why nitrito N? Nitrito N, okay. Nitrito N because it is ampidentate ligand, right? NO2 is an ampidentate ligand where N is connected. That is why it is nitrito N. Suppose if we write ONO, which means it is nitrito O. So nitrito N is possible, nitrito O is possible. Nitrito N means N is connected, nitrito O means O is connected. Is it okay? Understood? Yes? Now let us proceed. Okay. Now I have a bidentate ligand, that is En. En stands for ethane 1,2 diamine, right? It's a chelating ligand, bidentate ligand. So I can say the coordination number here is, then it has to be, okay, one more we can include here, Cl, okay. So then 1 Br will come. One Br out, okay. So how to name this? Actually the coordination number is 6 here because it's a bidentate ligand, so you should take it as 2 and each 1 1, right? So bidentate ligand, so 4 donor atoms, no, and 5 6. So total coordination number is 6 here. Is that okay? Now how to name this? Now we have chelating ligand, okay. So since it is a chelating bidentate ligand, we have to use the word bis. If it is 2, you should use the word bis. If it is 3, you should use the word tris. More than that they don't ask. Generally it will be bis or tris. Is that okay? So now you have the ligands also. You have a Br, you have Cl, right? So how to name this? Alphabetical order. Bromido, start with the, arrange by the alphabetical order. Bromido, chlorido, bis, ethane, 1,2 diamine. So bromido, chlorido, bis, ethane, 1,2 diamine, cobalt. Charge on the, you have to find out the oxidation state of cobalt, okay. So X, this will be 0 because it is a neutral ligand. So -1, -1, -1, -1 each charge, which is equal to, since this is -1 the charge on the complex will be +1, right? So X is equal to 3. So bromido, chlorido, bis, ethane, 1,2 diamine, cobalt 3, bromide, right? Bromido when you will use, bromide when you will use. If it is inside the complex, you will use the word bromido. That is a ligand. But outside, we never say bromido, okay? It's just the bromide because it's a counter ion. Is that fine? Yes? How will you name this? How to name this compound? You don't have any other ligands, you just have only En, right? So, and it is a bidentate ligand, chelating ligand, yes. So, how to name this? Tris ethane 1,2 diamine, okay, cobalt 3, right? Why 3? Because it's a neutral ligand, so the charge is 0, and since it has 3, directly you can take the oxidation state to be 3, okay. So, tris ethane 1,2 diamine cobalt 3 is the right name for this complex. Understood? So far we have done 9 IUPACs. Understood? One more I will give. This is called Brigid Ligand, okay. These are the ligands called Brigid Ligands which connects the two sides, okay. So, this is called what? Brigid Ligand. So, how to name this? Let us see. Okay. So, tetra amine mu hydroxo, okay, we can go by the alphabetical order. Mu amido, mu hydroxo, tetra amine, dicobalt. Now we have to find out the oxidation state. This is -1. This is, you can even use the cobalt here. Here also you can write, or at the end, because it is same only, no? So you can even write dicobalt, nothing wrong with it. And also you can even say it as bis as the compound, okay? So what I am trying to say, you can start with this side and end with the other side. That is one way of writing. Or if all the ligands, everything is going to be same, then you can put bis and put inside only one time and you can finish it off. That is also fine. Anyway you can write, okay. So now let us find the oxidation state. So it is 2x, no ma? So 2x minus 2 is equal to, it should be okay. So now let us make it as +4 here, then only we will get the oxidation state. Okay. So now what will happen? You will get +4. So 2x is equal to 6. So x is equal to 3. Cobalt 3. If you say ion also fine, if you don't say also fine, okay. So how to name the Brigid ligand complex? You have to start from one side and end with the another side, okay. So tetraamine mu amido mu hydroxo tetraamine dicobalt 3. The another way of writing is bis. You can put bis and write tetraamine cobalt okay. So mu amido and mu hydroxo. Okay. So mu amido, mu hydroxo, bis tetraamine cobalt 3. Okay. So even we can bring this ligand front side. Okay, ma'am. So there is no hard and fast rules for this alone, for Brigid complex alone. Okay, you can start from one side, end with another side, or you put bis and write the entire thing. Alright, that is also possible. But you have to be very careful while calculating the oxidation state, because here the oxidation state will be 0, right? It is 0 here. This is -1, this is -1. Accordingly, you have to find out. So cobalt mostly it will be 3 only. Cobalt will be mostly, it should be 3. Alright, rarely 2, but mostly it is 3. And even if you take nickel, 2 is the most probable one, 2. Alright, yes, understood? Hope you understood this video regarding the IUPAC of coordination compounds, how to name them. Yes? Thank you, students.